So question 5. So when the students look at this, it's quite a bit of information to take into account at the start. But as always, we say, read it a couple of times. We see the word empirical rule in there. So we know straight away something about the empirical rule. Hopefully we've heard it a few times. We know the idea that 68% of the values will be within one standard deviation of the mean. 95% of the values will be within 2 standard deviations of the mean. And it'd be 99.7% of the values would be within 3 standard deviation. And it's assuming, of course, that they are following the normal distribution. But as always, we'll read through it. It says North Dublin Oils Limited supply home heating oil to homes in the Dublin area and the surrounding hinterland. Of course, that part isn't relevant. You know what I mean? It's not going to affect anything. It's just part of the context of the question, the story. The volume in litres of oil purchased per home visit last month was recorded and analysed. The random variable X, where X is the volume of oil purchased, follows a normal distribution. It has a mean of 520 litres and a standard deviation of 80 litres. A customer is chosen at random. So like that, inside the exam, you'd want to read it a few times, make sure that you have, as clear as you can be before you start on what exactly it means. Use the empirical rule to estimate the percentage of customers or households that purchased over 680 litres. Well, we know what we were saying, that the mean, which is mu, would be the 520. The standard deviation is 80, and that would mean so that 68% of all customers would purchase between 440 and 600 litres. 95% would purchase between 680 litres and 360 litres. So that's 95% will be within these two values here, leaving only 2.5% to be lower than 360 and 2.5% to be greater than 680. And that's the answer to the question. It's going to be 2.5%. We could look at it this way as well. We could say 680 litres is equal to 520 plus 2 standard deviations. We know 50% of all the values are to the right of the mean, to the right of mu, 520 in this case. We know that 47.5% are going to be between the middle, 520, the mean mu, and 2 standard deviations above it, because that's half of 95%. So again, therefore, if I take the 50% and I subtract 47.5, I'm going to be left with that 2.5% in that red region there. And that's worth 10 marks. So the maths isn't hard if you have a good sense of what the empirical rule meant. Now we're asked to find the probability that any customer chosen at random would order between 460 litres and 700 litres. So we're going to use our formula, which is going to allow us to find the standard units. So we're told that this purchasing of the oil follows a normal distribution. On page 36 and 37, we get the probabilities for the standard normal distribution. And what the standard normal distribution is it has a mean of 0 and a standard deviation of 1. So we'd say 68% of all the values in the standard normal distribution would lie between -1 and +1. So the reason we have the standard normal distribution is to allow us go from a question like this, which is dealing with oil, into the standard normal distribution where we know the probabilities and we can calculate them. Okay, so what we're going to do is we're going to use this formula. Z is equal to x minus mu over sigma. X is the particular value in question, Mu is the mean, sigma is the standard deviation. So we're going to start off with finding the probability that any customer would purchase less than 700 units. So once we do our calculation, you'll see here 700 minus 520 divided by 80, that's 2.25. 2.25 standard deviations above the mean. So we're going to find that on page 37. So 2.2 is here, and I go out further to 2.25. That's 0.9878. Now, what does that mean, 0.9878? What that's saying is the probability that any z-score selected at random would be less than 2.25 standard deviations above the mean. That is 98.78. Now, that's the same thing as saying the probability of a customer purchasing less than 700, and it can be less than or equal to their equivalent, they're equal, that's the same, because the probability of having any particular value is 0, because there's an infinite number of values. So the probability that a customer purchases less than 700 units, that's the same as a probability of having a z-score less than 2.25 standard deviations above the mean. Okay, we want to then take away the probability that a customer would purchase less than 460 liters. So in this case, we're going to say, well, my x value, so my x value in the formula this time is going to be 460. I'm going to subtract mu 520, divide by sigma, which is 80, and I'm going to get minus 0.75. So the probability that a customer would purchase less than the 460 liters, that's going to be the same of the probability that a z-score would be less than or to the left of 0.75 standard deviations below the mean. Now we know that our table doesn't give us values using the negative. So I have to say, okay, the probability of having z-score less than minus 0.75, that's the same thing as the probability of having a z-score greater than plus 0.75. That's because of the symmetric nature of the curve. And that then is the same as 1 minus the probability of having a z-score less than 0.75. And that's what I'm going to look up. So I look up the probability of a z-score less than 0.75. Let me clear my screen here. So 0.7 is here, 0.75. So it's going to be 0.7734. Sometimes people get a bit confused with that because, you know, the 0.75 is quite close to the 0.7734, but they're different things. The 0.75 is the standard deviations. That's the number of standard deviations. The 0.7734, that's 77.34%. So I subtract that away from 1 and I get 0.2266. Now, what does that mean? It means that there's a 22.66% chance that any z-score would be to the left of 0.75 standard deviations. So now what my final answer is going to be is this orange region to the left of 2.25 standard deviations and to the right of minus 0.75. And of course, that is going to be the same when we're talking about the actual question. It's 700 liters on the upper side, and it is 460 liters on the lower side. I subtract one from the other, and I say the probability that a customer orders between 460 liters and 700 liters is 76.12%, 0.7612. Okay, so 10 marks for that. Now, our final part, some students will find this tricky. It says the following: the cost of oil remained constant at 0.89 euros per liter, 89 cents. That'd be good value if you could get it now. During this time period, given that 90% of the customers spent more than N euros on oil. Find the value of N correct to the nearest cent. So we're going to be dealing with a money amount here at the end. However, because the cost remains constant, that when we're thinking about the percentage in relation to the customers, 90% of the customers spent more than N euros. But what we can work out is we can work out what was the amount of liters that 90% of customers spent or bought more of or more than. We can work that out and then work out the bill that those customers paid. So in this case, what we're going to be doing is we're going to be figuring out that if I work out Z1 here, if I just look at Z1 here for a moment, I'm going to be working out a region that 10% of the customers are going to be in, because 90% of customers are going to purchase more and spend more than this amount. But maybe I'll just show this value here. We're going to be, I suppose, focused here on Z2, okay? Because Z2, if I'm saying 90% of the customers will have spent more than N euros on the oil, then 10% of the customers will have spent less than. So in this case, because we're still looking at the liters purchased, because we have the information on that, I can say that 90% of the customers will have purchased more oil than we'll find here at this Z value. So that's our job to do that. So remember again, the page 36 and 37 gives us the probabilities associated with the standard normal distribution. So if I go again to page 37, and if I look up my table, like what I'm finding over here on the right hand side, these values here relate to the probability of being less than a certain Z score. So if I look up here, the 0.8897, that's 89.97%. The 0.9015, that'd be 90.15%. So what do those relate to? What I'm saying is, in the standard normal distribution, the probability of being less than 1.28 Z scores to the right of the mean, that's going to be 89.87. And that's as close as I can get to 90. So that's the value I'm going to use. So what I'm saying is this: the probability of having a Z score less than Z1 is going to be 90%, or I can say the probability of a Z score greater than Z2 is going to be 90%, and Z2 is minus 1.28 standard deviations. Now we must figure out what that is in terms of the liters of oil. So here's my formula: Z is equal to X minus mu over sigma. At this point in the question, students might be finding it tough going, but sometimes you just fill in the formula. You say, okay, mu is 520, sigma is 80. I know what my Z score is, it's minus 128. And I say, right, I'll just keep going here, figure out what X is equal to. So multiply both sides by the 80, and then add 520 to both sides, and you get this answer here of 417.6 liters. And you'd say to yourself, well, okay, I'm finished, not quite, but let's see, does it make sense? What I'm saying is 90% of customers will have purchased more than 417.6 liters. We know the price per liter is 89 cents. So if I multiply my 417.6 by the 89, I am going to get the bill. Then the bill is going to be 371.664. And we know, of course, that we round to the nearest cent. So it'll be 371.66. And that was 10 marks. Now, that would be a tough question for students, because, they might have found the first parts maybe okay, but when you're coming into this last part, particularly when you have to go to the part where you're calculating the final bill, students might well find that to be tricky.